Dilations, properties and algebraic representations. How can dilations be described? Well, first of all, we have to remember about transformations. And a transformation is an image that describes a change in the position, size, or shape of a figure. Well, we were talking before about position. In position, translations, reflections, and rotations all make a change in position. The only one that makes a change in size is dilation. So it's going to obviously change the position because it does move it when it dilates a little bit, but it's going to make it either larger or smaller by definition of the word dilation. So what I want to do is take a look here. There is a video that's available on YouTube. It's called Scale Ella, and I want to show you just a little bit of it. It's by mathsmax.org.
No, not Scalio. It's Scalio. He's escaping.
I'm going to stop it right there. One of the things that you noticed with Scalio is that he can change the size of things, and that kind of relates to what we're talking about with dilations. So we're going to use that idea here and define it a little bit more. So dilation will change the size of a figure, but not the shape of the figure. So in order to define a dilation, you must find the center of dilation, which is the center of the figure, and a scale factor, the number used to multiply the vertex to get the figure. We're going to kind of take a look at that, but before we do, one of the things, if you watch that video all the way to the end, it kind of explains it a little bit better, but we can explain it here by definition. If the scale factor is greater than 1, so 1.1 and up, 1.01 and up, the dilation is going to enlarge. We know that something is 1 to 1, it stays the same. The fact that it goes larger than 1, that means that that figure will enlarge and get larger. Now, if the scale factor is between 0 and 1, in other words, it's a fraction like 9/10, 1/2, 3/4, that means the dilation is going to shrink the original figure or get a little bit smaller. So we're going to use those numbers, and we're going to kind of take a look at an example here. So here we have two triangles. We have a pre-image ABC and the image A prime, B prime, and C prime. And one of the ways that we can help us to figure out what's going on is by writing the ordered pairs. We can see it a lot clearer. So let's find the ordered pair for A, which is located right here at 1, 1. B is located at 1, 3. And C is located at 3, 1. Now when we write down the pairs for A prime, B prime, and C prime, we notice that A prime is located at 2, 2. B prime, 2, 2, 4, 6, is located at 2, 6. And C prime is located at 6, 2. Now, one of the things you have to think about, what's happening with the changes? 1 to 2, 1 to 2. Seems like it's going adding 1. When we go here 1 to 2 again, but 3 to 6. 3 to 6, 1 to 2. What's happening is the scale factor. That's the change. So what we see is going on is that it's multiplied by the number 2. If we take each of the numbers in the pre-image ordered pairs, all of these numbers, 1, 1, 1, 3, 3, 1, and multiply every single one of those numbers by 2, we would get this set of ordered pairs. So we would write that the scale factor is 2. And that's important. We need sometimes to find the scale factor. Because when we find the scale factor, then we're able to write the algebraic representation. So we'd say the original point changes, and because it has a scale factor of 2, we would put a 2 in front of both numbers because it changed by 2 on the x and also 2 on the y. And hopefully that'll give you a little bit more understanding about dilations and their algebraic representations.